Alkynes are not as important compounds industrially as alkenes. The most useful alkyne by far is acetylene. And much of its usefulness comes from the fact that it's able to produce very high temperature flame when combusted in pure oxygen. In air itself, acetylene burns with a lot of heat because it's such a carbon-rich compound, so not all the carbon can combust quickly. But when exposed to pure oxygen, acetylene burns with a very light blue flame, which reaches very high temperature, and is therefore used in welding. The reason why acetylene burns with very high flame lies in the fact that it produces a relatively small number of moles of compound at the end. And so there is not much stuff here really. It gets heated up to relatively high temperatures because all the reaction energy has to get distributed onto these three molecules, which is about 160 kcal per mole for each one of these moles. That's why the temperature of the flame in case of acetylene oftentimes reaches and exceeds 2800 degrees centigrade. And so this flame is such a high temperature that it's used commonly for melting steel, in welding, and also for cutting steel as well. Now the problem with acetylene is it's explosive. It's a gas which explodes under pressure, and pressure is sort of necessary because it's otherwise very impractical to transport it as a gas. However, fortunately, solutions of acetylene in acetone are much less prone to this explosive reaction, and that's how acetylene is typically transported as a solution, pressurized solution in acetone. This problem is also partially relieved by use of other alkynes such as propyne, also known as methylacetylene, which has similar combustion properties, but it's much less shock sensitive, so it's used in some specialized and household applications. Acetylene used to be historically a very important compound because it could be made directly from coal by reacting coal with limestone. One could make calcium carbide and CO, and then calcium carbide, after being exposed to water, hydrolyzes into calcium hydroxide and acetylene. And since the starting materials here are basically water, limestone, and coal, this was a very cheap process which gave an organic compound. And furthermore, it gave an organic compound which is reactive, has triple bonds that can be functional. So this used to be an entry into the whole organic chemistry because all the compounds used to be made from acetylene. However, with the emergence of oil as the predominant source of carbon, things change quite a bit because oil can be fractionated and is actually more convenient and gives us access to a broader range of organic compounds. So acetylene is still used to some extent, but not quite as much as it used to be used in the 19th century. Nowadays, a lot of acetylene is produced from natural gas, from methane. So if you heat this in the presence of catalyst at 1500 degrees, you'll get acetylene and 3 molecules of hydrogen, yes.